Hello friends, I'm going to start a new channel for data structure and algorithms. So I have uploaded few videos on my different channel for algorithm, not few, I think I have completed, I have covered all the sorting algorithms in that particular channel, but here I will start everything from very scratch. The channel is data structure and algorithm. So first we will cover what is algorithm, what is algorithm and why it is required, what are the different approaches for algorithm, we can say what are the different kind of algorithms and what kind of sorting are there. So in this particular channel, in algorithm part, I will cover almost everything. Why algorithm is required, what are the different kind of algorithms, it means divide and conquer and stable, in place, comparison, dynamic programming, greedy approach. So these are the different kind of algorithm. We will work on the theory part, then different kind of examples and all, and different kind of sorting algorithms are there as well, and we will learn how to calculate the complexity. So I'm talking about the master theorem and substitution method. So I will cover these things in my algorithm channels. So these are the most of the top of the elements I will cover. And in data structure part, we will start from array, linked list, array list, tree and all. So we'll cover what are these data structure arts and different kind of problems related to the data structures. So today this is my very first video, so I'm going to start what is the algorithm is. So algorithm means it is an step by step procedure to solve a problem. So you can be given any problem and you need to solve that particular problem. So what are the steps which you are supposed to take? That is called the algorithms. So to solve a similar kind of problem, different people can have different approaches. Okay, so let's say you want to assemble a car. Now if you ask two people to assemble a car, so they can have different approaches to assemble a car. One person can start to assemble the engine first, another person can start to assemble the body first, but the overall goal is they both will reach to a particular solution, that is called a single solution. That is, the solution is to assemble a car. So in most of our algorithms, when you start reading the algorithms, you find in every algorithm textbooks, you find to sort the element. You find the problems like to sort n elements, and we have different kind of approaches to solve n elements. You can go with merge sort, you can go with insertion sort, you can go with quick sort, bucket sort. So the objective is to sort the n elements and you can say that different person in an industry uses different kind of approach. Let's say the logic of these sorting algorithms are not given, and there are 4 person, and I ask those person to sort n elements. So you can assume that these are 4 person, and these are the approaches given by the 4 persons to sort n elements, but the objective is same. Objective is to sort the n elements, so output will be the same. Approaches are different, but output is the same. So algorithm means the approach. Algorithm means what is your approach? Collection of steps, you can say. Collection of steps to solve any particular problem. So that is called the algorithm. Most of the time we compare the different algorithms, means different solution given by different people, with the help of their performance. Sometimes performance is better, sometimes performance is worse. It means one algorithm given by one person is performing better, but one algorithm given by one person is performing worst. So now what are the different kind of parameters to analyze that your given algorithm is a better algorithm, a worst algorithms? So most of the time we talk about the 2 parameters. One is the time, second is the space. Time means how many CPU cycles will algorithm will take. The count of CPU cycles. Space means how much MB, GB, whatever, how much memory, I'm talking about the RAM, will be taken by your algorithms. Okay, so that these are the most important things which will decide that your algorithm, either your algorithm is better algorithm, is algorithm is the worst algorithms. And all these 2 will be calculated in the form of order, theta, and omega. So most of the time we use theta or omega, order of n, theta of n. So what does it mean? N is your input size, and you are supposed to give and this is representing the complexity. So complexity is a new word. If you are not aware of the algorithm, so complexity is a new word. So complexity means overall resources taken by your algorithm is called the complexity. So order of n means if your algorithm size is n, if your input size is n, then your algorithm either time or space complexity is order of n, means it will take the n CPU cycle. Okay, and if it is an order of n square, so it means whatever your input size is, your complexity will be order of n square. Okay, so this is the complexity. We talk about the complexity, and these are 2 terms. With the help of those we calculate the performance of a given algorithm. Now what is the data structure? Data structure means when you apply your algorithm, you need to store the intermediate result or the final result. So where will you store? You will store in a data structure. So data structure, you can say it is a container for storing the result. We have different kind of data structures for storing the result. You can go, and all have their own properties, means there are different some circumstances then when different data structure perform well, in different circumstances different data structure works well. So you need to decide according to your requirement which data structure you are supposed to use. Okay, so all the data structure store the data, but their performance is decided by insert and retrieval. Means, let's say if you insert one particular element in your data structure, then how much time will be taken by this operation if you insert one particular element in a data structure 1, and how much time will it take when you get back you get back your element which is already there in your data structure. So according to your requirement, you are supposed to choose the data structure. When you, let's say, if you want that your insertion should be fast, it doesn't matter retrieval is slow or fast, then you choose the different data structure. Suppose you want that your insertion can be slow but retrieval should be fast, then you can use the different data structure. Okay, so that depends on your requirement. Let's say if you want to insert fast, then you can use any unsorted DS. Okay, in unsorted DS means the elements will not be maintained in a sorted manner when you insert your element into a data structure. So you can place your element anywhere, but the retrieval will be slow because there is not any defined order of your elements in the data structure. But if you want the retrieval fast, then you need to store your element in a sorted data structure. Then your retrieval will be fast, but insertion will be slow because whenever you will insert an element in your data structure, you need to maintain the order. So according to your requirement, you need to choose your algorithms, and you also need to choose your data structure. So that depends on your algorithm. So how do you choose? I mean, how do you make this kind of choices? You only can make these kind of choices when you are aware of a different kind of algorithms and different kind of data structures. So we will cover almost everything. You need not to go anywhere. This is my very first video, so I will start from the algorithm. I will cover everything which will be required by you when you work in an industry, and after that you will start the data structure part. Thanks for watching. Please subscribe my channel.